guys, last thing for algebra, we are doing, it says quadratic regression, but we're really doing all the regressions. It says quadratic because you already know how to do linear regression. We did exponential regression yesterday, so all that's left is quadratic. But we're really going to do a mix of it to where you have to pick which regression to do. So like, just to review from linear regression, how do you find the line? That's how we know it's linear, it's a line. Containing the points -2, 5, and 6, 2. So that's where you need to put in your table and do your y1 squiggly mx1 plus b. So if I go to Desmos, I'm going to put plus table. I'm going to put my x's, -2 and 6. And then my y's are 5 and 2. And I come down here and I type in y1 squiggle mx1 plus b. And it tells me m equals -0.375 and b equals 4.25. So if I were to write this in standard form or slope-intercept form, I would just need to plug into y equals mx plus b. Well, now I know what m is. M is -0.375. And then b is 4.25. So y equals -0.375x plus 4.25. So we've been doing that since the beginning of the year, finding the linear regression to find slope and y-intercept and all that fun stuff. Now we've got to decide if the data is linear, quadratic, or exponential. So remember with linear, it makes a line. So linear is going to make a line. Exponential, remember that it grows exponentially. So it does something like this. There's a exponential growth. Right? And then quadratics make the parabola. So those are the different types of graphs we've talked about. So with line, we already know what the regression model is going to be, right? y1 squiggle mx1 plus b. And that's because standard form is y equals mx plus b, right? So we're just switching out and putting the ones and switching out the equal sign with the tilde. Exponential, the standard form was y equals ab times b to the x power. So again, we're just going to do y1, change out the squiggly, ab, and then x1. We did that yesterday. And then lastly with quadratic, remember standard form is y equals ax squared plus bx plus c. Same thing. We're going to do y1 squiggle ax1 squared plus bx1 plus c. So again, the only things we're changing is this equal, and then we're putting all of the ones in here. Same thing over here, equal, and then we're putting all of the ones in there, just like we did here. So that's all we're going to do. So these first ones tell you what to do. When we get to the back, you're going to have to figure out which regression model to use. So this one says we're going to use quadratic regression. So that's the y squiggly, y1 squiggly, ax1 squared plus bx1 plus c. So first step is to plug this into Desmos. So I'm going to go to Desmos and let's clear this out. Let's make a table. So plus table. My x values, I've got 2.9, 3.9, 4.7, 5.6, 6.9, 7.7, 8.5, and then my y's 8, 14, 23, 29, 40, 53, and 70. Now, since it's a quadratic, here's where I'm going to do y1 squiggly, ax1. I've got to square it. So again, I can either do shift 6 or I can come, this thing has got to go. You can go over here. Okay, and then I've got to do shift 6 or I can press this A to the B and that moves it up to where I can type in any number. Be sure to arrow back down, plus bx1 plus c. So now it tells me what A, B, and C are, right? So A is 1.19-ish. B is negative 3.13. C is 8.33. So now if I put it into my standard form, I'm just plugging into y equals ax squared plus bx plus c. I know A is 1.19. I know B is negative 3.13. And I know C is 8.33. So it's y equals 1.19x squared minus 3.13x plus 8.33. And it wants to know what is, if x is 4, what is the value for y? Well, everywhere we see an x, we're just going to plug in, we're going to plug in 4. So again, I just took, and everywhere I saw an x, I put in 4. And I'm just going to plug that into Desmos. So 1.19 times 4 squared minus 3.13 times 4 plus 8.33. And I get 14.85. So super simple. You're just plugging things into Desmos. Just remembering those standard forms, and a lot of standard forms are on your formula cheat sheet. Hard to say. And you just have to remember to put those ones and the squiggles and all that fun stuff in there. So again, this one's quadratic regression. Number 2 is quadratic regression. So I'm going to skip that one. If you want the answers to check yourself, the equation is y equals negative 4.6 x squared plus 50.89x minus 113.44. Ran out of room, and then you plug in 4, it's going to be 15.88. Same process as above. So again, check your work, see if you did it right, pause the video, and make sure you know how to plug it in. Okay. So this next one, it's kind of the same, a little bit different. It says the revenue of a company based on the price of its table. So I'm going to first, we're still talking about quadratic. So I'm going to plug this all into Desmos. Plus table at 1, 2, 2.75, 4, 4.5, 6, 8, 8.4, and 9. Then I'm doing 90, 228, 303, 384, 406, 396, 282, 229, and 135. Again, quadratic regression, y1 squiggly, ax1 to the second power plus bx1 plus c. When I do that, it gives me my a, my b, and my c. So if I were to write my equation, it would be y equals negative 18.43x squared. Well, I guess I'll show you what I'm doing. And then we're doing plus 191.44x minus 83.36. Okay, so now notice when it gives me a picture of what's happening. So it's a parabola and it's facing downward. And I already knew it was facing downward because of the negative. So because of this negative, it's going to be facing downward, right? So it says, how much should the company sell the product to maximize? When we're talking about maximize, we want the greatest. What is going to be the greatest profit we can get? Well, that's the highest point. In our case, the highest point is the vertex because it's facing downward, right? So if I look at my vertex, $5.19 is going to maximize that. Okay. Okay, here's kind of what you're going to have to do. You're going to have to figure if it's linear, quadratic, or exponential. And here's how you're going to figure out which one to do. So you're going to plug all this data into Desmos. I know. It's so fun. Plug all of this data into Desmos table. We're going to have -2, 0, 2, 4, 6, 8, 10, 12, and 14. No, 14. And then -5.75, 1, 6.25, 10, 12.25, 13, 10, where are we at? 12.25, nope. 12 is 10, and then 14 is 6.25. Okay. So as you can see, these points are kind of here. A lot of times you might not see the points. Like I was so zoomed out so we can see them. But if you hit this little magnifying glass right here, it says zoom to fit, and it'll make it fit your screen. So now you can see all of your points graphed, and you can determine what shape it's making. So if you look, it's definitely not linear. It's not a line because we've got this curve. It's not exponential because remember, exponential is going to go up like this or like this. This is going to be more of a parabola. If we were to do more points, it would be coming down. So this is going to be a parabola, which means it's a quadratic regression. So quadratic, we're doing y1 squiggle, ax1 squared plus bx1 plus c. So I'm going to plug that in, and we'll figure out what we get. Y1 squiggle, ax1 squared plus bx1 plus c. So notice it draws the line of best fit through it, and it gives me what my a, b, and c are. So when I write this, it's going to be y equals -0.19x squared plus 3x plus 1. So again, you're just plugging in your points and you are figuring out what's happening with it. So that's really all there is to it. I'm not going to do the others because y'all can plug in a table and figure out what it's doing. But that's all there is to the regression. Bye, y'all. Have a great day. Congrats. You just finished Algebra 1. Bye, y'all.